Hello students, welcome you to this session. So in this video, I am going to teach objective questions, that is MCQs from the first chapter, sets, relations and functions. So hope you are thorough with all the theory part. So if you are thorough with the theory part, these sums will be very, very easy for you. Okay, now let us see the sums one by one. Now the first question, A equal to set of ordered pair x comma y such that how they are related y equal to e raised to x. Y equal to e raised to x. X belongs to R. X is any real number. Y equal to e raised to x. And B, same way only they defined, but only thing y equal to e raised to minus x. The first one y equal to e raised to x, second one y equal to e raised to minus x. In both the cases, x belongs to a set of real numbers. The question is, then n of A intersection B. How many elements are common for A and B? So A is an ordered pair, right? B is also an ordered pair. We have to see how many elements are common. How many elements are common means, so the common ordered pair you have to get. So when you give some x value, in both the cases, both the y values must be same, right? So in one case y equal to e raised to x, and in the another case y equal to e raised to minus x. When you put x equal to some value, here you find y value, here also you find y value, both the values must be same. Then only it comes in what? A intersection B. So if I substitute 1 here, e raised to 1, e raised to minus 1, they are different, right? If I give minus 1, e raised to minus 1, e raised to plus 1, right? But when I put 0, e raised to 0, it is 1. E raised to minus 0, that is also what? 1 only. So here the first one 0 comma 1, in second one also x value 0, y value 1, and this is the only one element which will come common for what? Both A and B. So number of elements in A intersection B is what? Only one. And what is that number? 0 comma 1. Okay, that is the only one element. So third one is the correct option. Now let's go for the next question. Please listen here. Similar question only. Instead of n of, they asked A intersection B contains. So again we have to find the number of common elements for what? A and B. Similar question only, but they define y in different way. That instead of e raised to x, here they put y equal to sin x, and another one y equal to cos x. Y equal to sin x and y equal to cos x. But these images must be same, right? Y is the answer. So that must be same. So you have to get sin x and cos x are same. Sin x and cos x are same. The previous question, e raised to x and e raised to minus x are same. Only when x is equal to what? 0. So like that only actually you are getting 0. So here also sin x equal to cos x. Bring that cos x to the denominator. So sin x by cos x equal to 1. So tan x equal to 1. So immediately you say tan x equal to 1. You say x is equal to what? 45, right? X is equal to 45 degrees. So you may say there's only one element. That is in 10th standard, right? Tan 45 is 1. But now trigonometric functions has infinite number of solutions. Already I taught in another video, right? So this can be written as tan x equal to 1 can be written as tan 45, tan pi by 4. This is of the type tan theta equal to tan alpha, tan theta equal to tan alpha, then theta is equal to, instead of theta we have what? X, theta is equal to n pi plus alpha. So that is x is equal to n pi plus alpha, alpha value pi by 4, where n belongs to z. This is the general solution of the equation tan x equal to 1. So don't think tan x equal to 1 means it has only one solution. X equal to pi by 4, of course, that is one solution. That is one of the solution. There are infinite number of solutions. Okay. How do you know there are infinite number of solutions? N belongs to z. Z is set of integers. So you put 0, 1, 2, 3, etc. You put minus 1, minus 2, minus 3, etc. in this answer. Whatever you get, everything solution. So how many solutions are there? There are infinitely many solutions. So second one is the correct answer. Now let's go for the third question. The relation R defined on set A. The given set is 0, minus 1, 1, 2. by x is related to y, you can say x is related to y. If that condition satisfied, what's the condition? X square plus y square is less than or equal to 2. X square plus y square is less than or equal to 2. So let us find what are the elements in R. Please listen. So 0, minus 1, 1, 2. So A to A only. Okay. So here 0 if I take, the condition must satisfy. So square the element, add it, square two elements, add it, the total must be less than or equal to 2. Up to 2 it can be, right? So if I take 0 here, 0, comma 0 you can take. Here 0, 0. Because if I substitute 0 square plus 0 square, take modulus, the answer is less than 2. 0, comma minus 1 you can use, 0, comma minus 1. 0, comma 1 you can use, 0, comma 1. X is 0, so 0 square, 1. 1 square is 1. So totally you are getting 1, less than 2 only. But 0, comma 2 you can't take. Why, 0, comma 2 if you take, x you put 0. So the first term is 0. Y is 2. So 2 square, 4. Less than or equal to 2. No, it's wrong. So you can't take 0, comma 2. Then minus 1, comma what? Minus 1, 0 you can take. Minus 1 you can take. Minus 1, 1 also you can take. Because it can be 2. If I give minus 1, 1, minus 1 square, 1, 1 square, 1, add it, it is 2. So less than or equal to 2. Up to this you can take. You can't take minus 1, comma 2. Minus 1, comma 2 you can't take. If I start with 1, 1, comma 0, 1, comma minus 1, 1, comma 1, 1, comma 2 you cannot take. Okay, actually this is the relation here. But here they given some R. So which of the following is true, they ask. The first one is true or not. So some elements they given. Check whether every element satisfy the condition. It won't satisfy. 1, comma 2. You substitute and see. For x you put 1, 1 square plus 2 square, 4, right? So it is 5. Less than or equal to is wrong. So first one is not the answer. R inverse. If some R inverse means the reverse one. So if I take something like this, for example 0, comma 1. 0, comma 1. The inverse function is 1, comma 0. So 1, comma 0 is there. But if I take 1, comma minus 1, 1, comma minus 1, it is in R. So R inverse, the reversed one, right? 1, comma minus 1, it is not there. Okay, 1, comma minus 1. Even 1 is not satisfied. You can't take it as R inverse. Domain of R. Domain means which values you can give for R. For R, you can give 0. Okay, so for X and Y. So what values you can give? Okay, the first value, first one. For X, which values you can give? So 0 you can give, minus 1 you can give, 1 you can give, 2 you can't give. Why, for X you put 2, whatever value you give Y for Y. 2 square is 4. So 4 plus Y square, it's a positive number because Y square is there, right? So 4 plus a positive number, you cannot say less than or equal to 2. It may be even 0, but still 4 plus 0 is also more than 2, right? So it won't satisfy. So in domain, this 2 won't come. So that option is also wrong. If they say the domain is 0, minus 1, 1, it is correct. But here the correct answer is range of R is 0, minus 1, 1. So range means the Y values. So Y values can be 0, minus 1, 1. Okay, so the fourth one is the correct option. Just try to understand the reason for that. Okay. Now let's go for the fourth question. It is in modulus. So only one simple concept you need. Modulus x has two values. It is x itself if x is positive, greater than or equal to 0, and is minus of x when x is negative, right? So here please listen here. f of x is modulus x minus 2 plus modulus x plus 2. This is f of x. Since modulus is there, so every part, actually there are two parts. It has two values, right? So let me see the breakpoints first. X minus 2. If I take x minus 2, 0, x equal to 2, right? X equal to 2 is one point. Then the another one is x plus 1. If I put x plus 1, 0, you get x equal to minus 2, right? X plus 2, 0, you get x equal to minus 2. Here minus infinity and here plus infinity. So these are the intervals. Minus infinity to minus 2, minus 2 to 2, 2 to infinity. Okay, these are the... Now please listen here. Now first, what do you do, no? This, the first one I am taking it as A. First one you take it as A, second one you take it as B. So you have to find the values of what A and B. Okay, now please listen here. A has two values actually. A is modulus x minus 2, right? A is what? Modulus x minus 2. It is x minus 2 itself. Modulus x is x itself when it is positive, right? When x minus 2 is positive. X minus 2 positive means x is greater than what? 2. When x is greater than 2, that is in this area, right? When x is greater than 2, only in that area, it is what? X minus 2. It is x minus 2. In other areas, it is minus of x, right? Minus of x means for that x minus 2, you put a minus sign. So by that minus you multiply minus x plus 2. So this is minus x plus 2. This is also minus x plus 2. This is our a value in all the three ranges, okay? Now let us find b value. What is b here? b is equal to modulus of x plus 2. It is x plus 2 itself when x plus 2 is positive. X plus 2 positive means x is greater than minus 2. When x is more than minus 2, it is x plus 2. More than minus 2 means this side, right? Minus 2's right side. So here it is x plus 2. When more than minus 2 is right side, x plus 2. That means in the other side, minus of x. That means here it is minus of x plus 2. So change the sign, minus x minus 2. So the first one is a value, second one is b value. Actually what we need is a plus b. So add it. If you add these two, see what you get. Plus 2 minus 2 cancel, minus x is what? Minus 2x. So the first answer is minus 2x. Second one you add it, minus x plus x cancel, 2 plus 2 it is what? 4. Next one you add minus 2 plus 2 cancel, x plus x is what? 2x. So these are the three values you get. Minus 2x, 4, 2x. Minus 2x, 4, 2x, right? So in the first interval, minus infinity to minus 2, it is minus 2x. So minus 2 to 2, it is 4. And 2 to infinity, it is what? 2x. So the correct answer is the first one. Okay. So a little lengthy one, but don't think, sir, it's a little lengthy one, so I'm going to just mug up the answer alone. Don't do that. Okay. You have enough time, so please learn the method. Because same question, if they ask us a 3-mark question, what will you do, right? So better. Since you have enough time, you can learn properly. Okay. Now let's go for the next question. Listen. Let R be a set of all real numbers. Consider the following subsets of R cross R. S equal to set of all ordered pairs x comma y such that y equal to x plus 1, y equal to x plus 1 and 0 less than x less than 2. That is S. And T is set of ordered pairs x comma y such that x minus y is an integer. X minus y is an integer. Okay, so now please listen here. Now we have to check whether they are equivalence relation. We have to check which one is what? Equivalence relation here. Now first let us see S. For S, the function is y equal to what? X plus 1. But x lies between what? 0 and 2. But don't take 0, don't take 2. You take a number in between 0 and 2. For example, I'm taking 1. For x, I put 1. What is reflexive? Every element related to itself. If I put x equal to 1, y also will get what? 1, right? So you put x equal to 1 and check. When I put x equal to 1, y equal to 1 plus 1, it is 2. It is not equal to 1, right? 1 is related to 1, you have to get 1 comma 1. So you won't get 1 comma 2 only you are getting, right? So it is not reflexive. It is not reflexive. When it is not reflexive, you say it is not equivalence relation. No need to check other relations. Symmetry, transitive, no need to check. Because equivalence means it must satisfy all the three. So once it is not reflexive, you say it is not equivalence. So S is not equivalence, right? Now let us see T. X minus y is an integer. When can you say that relation T, the relation exists? You take two elements, take the difference if it is an integer, right? X minus y is an integer. Check whether it is reflexive or not. For x and y, you give same number. X you put 5, y also you put 5. So 5 minus 5. What is 5 minus y? 0. It is an integer. Some other number you put, say minus 2, minus 2, minus 2, minus 2, minus 2, right? Minus 2, x value minus 2, minus y value also minus 2. So minus is plus. So minus 2 plus 2, it is what? 0. It is an integer. So every element related to itself. So you know it is what? Reflexive. So reflexive satisfied. Reflexive satisfied. Symmetric you check. If A is related to B, B must be related to A. So if x minus y is an integer, what about y minus x? That is also integer. What is 5 minus 3? It is 2. It is an integer. What is 3 minus 5? Minus 2. That is also an integer. If 5 is related to 3, then 3 is also related to 5 only. So it is symmetric. Transitive, please listen. Suppose A minus B, your answer is one integer. B minus C, your answer is an integer. Then if we find A minus C, that also will be an integer. See small example. What is 5 minus 3? It is minus 1. It's an integer. 5 minus 3. Now I am taking 3 and 5. 3 minus 5. It is minus 2. That is also an integer. So 2 is related to 3. 3 is related to 5. Then you check whether 2 is related to 5. You check whether 2 is related to 5. 2 minus 5. What is that? Minus 3. That is also an integer only. So transitive also satisfied. So it is an equivalence relation. Are you able to understand? So first relation is not equivalence. S is not equivalence, but T is equivalence. T is an equivalence relation, but S is not an equivalence relation. That is the correct answer. Second option, neither S nor T is equivalence. Both S and T are equivalence. S is an equivalence, T is not equivalence. No, here S is not equivalence. So they given the second part. Okay, sometimes you get everything correctly, but while writing the answer, you should not miss that one. Okay, so first one is the correct answer. Now let's go for sum number 6. Listen to the sixth question carefully. Let A and B are subsets of the universal set N. Just I'm drawing a rough diagram. So this is one set A, this is another set B. A and B are two sets. Both are subsets of the universal set, and the universal set is what? N. Just an objective question, I'm drawing roughly, okay. If it is a 2-mark question or 3-mark question, you draw properly. Otherwise, you can do in a rough work, you have to do and write the answer. Question number, option, answer. That only they see for that, okay. Calculation you do somewhere, but try to understand and do, okay. Now, please listen here. So, we have to find the value of this. It looks lengthy, right? But it's a very, very simple one. Just try to understand, listen. Union, A dash union. Then what do you have? A dash union A intersection B union B dash. So A intersection B, you take only this A intersection B something, this portion A intersection B. Then other two are unions only. With this you have to add A dash. Which one is A dash? A is outside fully. A is outside fully you take. A is outside fully you take. Okay. So A is outside you take. And now union B dash. So B is outside also you take. B is outside. Leave B. It's outside fully you take. Everything you can take. Okay. We are not going to take the common portion. Everything union. So which portion left out now? Anything left out? No. The entire universal set we shaded. Right. So your answer is a universal set. But what is the universal set here? N. That's all. Okay. So it's very simple sum. So A intersection we shade first. So with that you have to shade B dash, also you shade A dash, everything union only that A intersection is, that is intersection, right, that portion. So that is one set, A dash is one set, B dash is one set. Now for all the three you take union only. So the entire portion you are getting, that is set of natural numbers. Okay, now let us see the sum number 7. The number of students who take both maths and chemistry. So whenever you have sums like this, better use Venn diagram. So maths and chemistry. So I'm taking maths, chemistry, both it is what? 70. This represent, that means this 70 represent 10%, 10 by 100, those who enrolled in maths. 70 is for what? Both. So 70 students take both maths and chemistry, and this represent, that is this 70 is 10% of total enrollment in what? Mathematics. Okay, so 70 is equal to 10% of total maths. So from here you can find m, 10 cancel, cross multiply, m equal to 700. M equal to 700. So inside m we need 700, but already 70 we have written, so write the balance 630. Now you see, and this represents 14% of enrollment in chemistry. 14%. This represent means 70. That common value, right? 70 is 14% of those who enrolled in what? Chemistry. So now can you cancel? 14 and 70 cancel, you are getting 5 times. Okay. Now cross multiply C equal to 500. So inside C you have to get 500, but already written what? 70, right? So 500 minus 70, you will get 430. Okay, you are getting 430. Now see what they asked. The number of students who take at least one of the two subjects. At least one of the two subjects means the entire portion A union B. Okay, so you have to add all the three. So our answer is 630 plus 70 plus 430. All the three you add it, you will get 1130. 1130. So the correct option is the second one. Now see sum number 8. Listen very carefully. Very simple concept you need. N of A cross B. N of A cross B is N of A into N of B. Now please listen here. This part they given, right? So N of A cross B intersection A cross C, they have given us what? 8. Now please listen here. N of, this can be written as, the term inside the bracket can be written as A cross B intersection C. Is it correct? Please expand and see. A cross B intersection A cross C, right? Like distributive, right? Now listen here. Now this is of the type N of A cross B. So this full part you take it as what? B. So you can write it as N of A. So the right side is 8, right? It's not 0. N of A into N of B intersection C is equal to what? 8. Substitute the known values. N of A we don't know. That's what we want to find. N of B intersection C is 2 equal to 8. So you can find N of A equal to 8 by 2. 8 by 2, the answer is what? 4. Now see the 9th question, similar question only. We want this portion, right? So what do we need? N of A cross B union A cross C. This is what we want to find. Can be written as N of. See, A cross is there in both. So you write A cross. What's the remaining? B union C, right? B union C. You can split into 2. N of A into N of B union C. What is N of A? It is given in the question 2. N of B union C 3. So 2 3s are 6 is your answer. Okay. Now let's go for question number 10. Two sets A and B, have 17 elements in common. Two sets A and B have 17 elements in common. Then the number of elements common to A cross B and B cross A will be the combination of these 17 only. So 70, the common element only what? 17. Using that 17, how many ordered pairs you can form? So 17 into 17. So 17 into 17. So 17 square is your answer because only the common elements. So 17 elements are common for both A and B. The question is common elements for A cross B and B cross A. These 17 elements are common for both A and B. Using that 17 elements, how many ordered pairs you can form? Okay. So that is 17 into 17. So they no need to multiply. They given the answer as what? 17 square. That's enough. Now let's go for sum number 11. Similar question only. A is a subset of B. A is a subset of B. So what is common for both? A is common for both, right? So then what they asked here, A cross B intersection A cross C. A cross B intersection A cross C is equal to, they asked, right? So for a non-empty set A and B, A is a subset of B. A is a subset of B. So here also intersection. Intersection means what? Common elements. So what is common here? A is common, right? In both the cases, A is common. So like 17, it is A. When 17 is there, your answer is 17 into 17. Now here A is common. So the answer is what? A cross A is your answer. Okay. Now look at this question. The number of relations in a set containing 3 elements. So number of relations, the set containing 3 elements, the formula 2 raised to n square. Instead of n, it is 3, so 2 raised to 3 square. So that is 2 raised to 3 square is 9. So the answer is 512. Okay. But question can be asked in different form. How many reflex relations are there? How many symmetric relations are there? So just to show the results. So you can learn that. If you know these results, then you can answer any question of this type. Number of relations, the formula 2 raised to n square. N is the number of elements. Number of reflexive relations. Among that relation, how many relations are reflexive? 2 raised to n square minus n, it is the power. Number of symmetric relations, 2 raised to the power, you write n square plus 1 by 2. And number of relations which are symmetric and reflexive and symmetric, 2 raised to n square minus n by 2. Okay, so learn these things. So question can be formed in any way. Look at the next one. Let R be the universal relation. What is universal relation? You know there are two extreme relations, right? Empty one, another one is what? A universal relation. Empty relation, it is not an equivalence relation, right? Because reflexive, every element, some element should be there, okay? But universal set, it is the largest relation, okay? Which satisfy equivalence property. So here R be the universal relation. Already I said it follows equivalence relation, right? It is an equivalence relation. So that means it is reflexive, it is symmetric, and it is transitive. But here equivalence, that it is not given. So you have to select the best option among the given one. So correct answer is equivalence relation. The universal relation is an equivalence relation. It satisfies reflexive, symmetric, and transitive. But that option is not there, so you can't take that. So not reflexive, you cannot take. Because it is equivalence relation, it must satisfy. Not symmetric, don't take. It is transitive, yes. So among the given options, the best option is what? The third one, it is transitive. Now we go for sum number 14. Listen carefully. X is 1, 2, 3, 4. Then one relation given, now they are asking whether the 4 option, reflexive, symmetric, transitive, or equivalence. Okay, if all the 3 satisfied, you say equal. If it is reflexive, don't immediately put the tick on that. You check for what? Symmetric. You check for transitive, then only you go for the conclusion, okay? First, let us check for reflexive. Reflexive means what? Every element must be related to itself. Every element. You cannot leave even a single. How many elements are there? 4 elements. So every element must be related. All the 4 elements. One means 1 is related to 1. 1 comma 1 should be there. Yes. 2 is there. So 2 comma 2. Yes, it is there. 3 is there. 3 comma 3. Yes, it is there. 4 is there. 4 comma 4 missing. So it is not reflexive. Are you able to understand? Every element must be related to itself. So the reason, just till you can write, but same question they can ask us a 3-mark question or 2-mark question. So everything with proper understanding. Don't think it is a 1-mark question. Just the answer is enough. Of course, 1 or 2 from the book, if you get a few, at least I am expecting 50% a question from the book directly. But you don't know whether it's from the book or not. They can make some changes. Okay, so try to understand and learn. So then you can answer any question. Please listen. So reflexive, it is not reflexive. What's the reason? Because 4 comma 4 is missing. 4 comma 4 is not there. 4 comma 4 is not in R. So it is not reflexive. So this option you cannot take. Symmetry, you check it. You check whether it is symmetry or not. Symmetry condition. If A is related to B, then B must be related here. That's all. 1 is related to 1, even if you reverse, the same thing. 1 is related to 2, 2 must be related, yes. 1 is related to 3, so 3 must be related to 1, yes. Then 3, 3. 1 is related to 4, 4 is related to 1. So what you understood from here, if A is related to B, then B also related to A. So it is symmetric, correct. So definitely it won't come equivalence. If transitive means only one option only, no? Anyhow, we'll check it. Suppose it's a 5-mark question or 3-mark question, you need that, okay? So transitive, if they ask you to check everything, you check. If they ask you to check only whether it is equivalence or not, no need to check everything, right? Once it is not reflexive, you stop there. It is not reflexive, so it is not equivalence relation. If it is reflexive, then you check symmetry. Suppose if it is not symmetry, stop at that point. You say it is not equivalence relation. If it is symmetry property satisfied, then you check for what? Transitive also, okay? But some question they'll ask, check the following relations. Reflexive relation, reflexive, symmetry, transitive, and equivalence. Then you must check everything. It may not be reflexive, but now it is what? Symmetry, right? Transitive, please listen here. What is transitive? If A is related to B and B is related to C, then, condition is there. A is related to B and B is related to C, then A must be related to what? C. It must be true for, if the condition is satisfied, it may be condition for satisfied for some pair, but some of them won't satisfy. Even it is not satisfied for one, you say it is not transitive. Okay, so you can say many examples which satisfy. I'm going to give some examples which do not satisfy. Okay, please listen. 4, 1 is there, right? 4, 1, 4, 1, A is related to B. 4, 1, then you start with 1. I'm taking say 1, 3. This is like A related to B and B related to C. Then you have to check whether A is related to C. You have to check whether 4, 3 is there. 4, 3 is not there. 4, 3 is not there. So it is not transitive also. So which is the correct answer? Symmetric. Okay, that's only one thing. Now let us see the next question, sum number 15. So this is to find what? Range. There are two types of questions, domain and what? Range. So read the question very carefully. The 15th question, they asked us to find the range. So that means this lies between which number? Okay. So which interval it lies? The final answer. Domain means what values you can take for x. For that, what do? You put the denominator 0, right? So excluded values you find out, then r minus that values. Okay. So when they ask range, so you know the range of sin x. Sin, you start with either that is a sine or they give cos. Both sine and cos must lie between -1 and +1. So since it is sin x, you say -1 less than or equal to sin x less than or equal to 1. Now you have to get the whole fx, right? So you know when the inequality reverses. When you change the sign, the inequality reverses. When you take reciprocal also, the inequality reverses. So sin x we have, but before sin x what do you need? -2. So you multiply by -2. Multiply by -2. So no need to mug up anything. Why we are multiplying by -2? It is there. So first see the sin x is there. Then before that -2. So you have to multiply by -2 in the next step. Then before that you have 1. So in the next step you have to add 1. You have to add 1 in the next step. Then after that 1 by next step you have to take what? Reciprocal. All these things you have to do. Then finally you take that as what? F of x. Okay. So first multiply by -2. You are multiplying by a negative number. When you multiply by a negative number, the inequality reverses. Okay. So when you multiply by -2, -1 into -2 plus 2 less than or equal to become greater than or equal to -2 sin x. Again less than or equal to become greater than or equal to 1 into -2, it is -2. So, okay. So now -2 sin x. Adding 1 now, right? Adding 1. With every term. So first one you add 1, so what do you get? 2 plus 1, 3. Great. So when you add a positive number, when you add something, whether you add positive number or negative number, there won't be any change. When you multiply or divide by a negative number only, the inequality reverses. So adding 1, so 1 minus 2 sin x. Adding 1, you are getting -1. Now the next step, 1 by we need, right? So we take reciprocal. Taking reciprocal. When you take reciprocal, also the inequality reverses. See, they given us a 1-mark question. Have you noticed these type of questions in the exercise? Yes, they can ask even as a 5-mark question or 3-mark question. So now they get asked as a 1-mark question. Okay. So taking reciprocal, when you take reciprocal, the inequality reverses, right? So see the first one, 3 reciprocal, 1 by 3. Greater than or equal to become less than or equal to. Reciprocal of the second one, 1 by 1 minus 2 sin x. Again less than or equal to -1 reciprocal is 1 only. Okay. And this part is our fx. Okay. Take that as fx. So next step what I'm going to do, 1 by 3 less than or equal to f of x less than or equal to -1. Now we take the part 1 by 1. First we take this part alone. You read from here f of x is 1 by 3 less than or equal to fx. Or fx is greater than or equal to 1 by 3. F of x is greater than or equal to 1 by 3. Another one is f of x is less than or equal to -1. F of x is less than or equal to -1. So please listen here. So which portion will come? Can you say? Listen, suppose you take a number line. -infinity to +infinity. 1 by 3 is in the right side, right? 1 by 3. -1 is in the left side. -1. F of x is greater than or equal to 1 by 3, greater than or equal to 1 by 3. So this portion. So 1 by 3 to infinity, greater than or equal to 1 by 3, right? Another condition says f of x is less than or equal to minus 1 and lesser values. So both these portions you have to take. So the first one is minus infinity comma minus 1. Minus 1 is included, closed interval, union 1 by 3 comma infinity. Okay, this is the option. So I think this is the fourth option. Okay, hope you understood. So it is not at all actually one mark question, right? Few questions will be like this. If you remember exactly the question number, everything, okay, write the answer. Otherwise, please work it out and see. So this type question they can ask in other part also. So understand the proof. Next question you see, question number 16. The range of the function, okay, the range of the function modulus of greatest integer function of x. That means you mark in the number line, take the left side number, right? Suppose greatest integer function of 2.7 means you mark in the number line. So 0, 1, 2, 3. 1.7 is somewhere here, it's left side integer. What is that? 2. So your answer is what? 2. Like that you find the greatest integer function minus x, where x belongs to r. Anyhow, finally you take the modulus. Modulus means your answer will be what? Positive range. So the answer only they are asking. They are not asking which values you can give for x. X belongs to r. That's the domain. So what answers you get? So modulus. So definitely your answer won't be negative. You will get the positive value. So 0 to only 0 you can take. If I take 0, suppose what is given? Modulus of x, greatest integer function of x minus x, right? When I put x equal to 0, the modulus of 0 minus 0 only. So greatest integer for an integer part, that itself. Okay, some decimal only. Suppose 1.7, you take the left side integer. Okay, so for 0 it is 0 only. So 0 minus 0, the answer is 0. So okay, this is one value. Suppose you take another some number. Suppose I am taking say 2.5. So where is 2.5? It is here, right? So which answer you get? 2 here, right? 2 minus 2.5. 2 minus 2.5 is 2 minus 2.5 is minus 0.5. But when you take modulus, it is 0.5. So first one you are getting 0. 0.5 you are getting. Suppose I am taking 7.9. I am taking 7.9. So what do you get? 7.7 and 8. So 7.9. The greatest integer function is what? 7. So if you substitute here, modulus 7 minus 7.9. So your answer is minus 0.9 when you take modulus value 0.9, right? So when you take any value, your answers will be like this. It can be 0, it can be anything. So it won't take 1, it will be slightly before 1. That means the open interval 1. 0 is included. So your answer is 0 to 1. So third option is the answer. Any value you give, it won't exceed 1. It won't be even 1 also. Slightly less than 1 only you get. It can be 0. So 0 to 0 is included, closed interval. But 1 is not included. So the right end is what? Open. Okay, so that. Hope you understood that. Now let's go for question number 17. Listen, the rule f of x equal to what? X square is a bijection. Bijection means it is 1, 1 and on 2, right? If its domain and codomain are given by domain and codomain, fx equal to x square, right? Bijection means both 1, 1 and 1, 2, right? Suppose if I take minus 2 and plus 2, fx equal to x square. When is square? Minus 2 square. It is 4. 2 square also what? 4. It is not 1, 1. So it cannot be like this. So you can't take the negative values, right? You can't take the negative values. Only is positive values. 0, 1, 2, 3, etc. Only positive values you take. Now listen here. Is it 1, 1 now? 0, 0 square. Here also take the positive values. 0, 1, 2, 3, etc. Right? So 1 square is 1, 2 square is what? 4, right? So it is 1, 1 and on 2 you will get. So here also set of real numbers only. Set of real numbers. So all the decimals will come. So don't think it's square root. It will be there only. Okay, 2 square root, 1.414. After 1, it is not 2. It will take all the decimals. Okay, so 0 onwards. So here what answer you get here? Only the positive values. So 0 to infinity. 0 to infinity. And the range also will be what? 0 to infinity only. See the 18th question. The number of constant function. Please listen here. Suppose in the first set, there are 2 elements or say 3 elements, A, B, C. In the second set, Suppose there are two numbers, 1 and 5. Constant function means every element related to the one number, right? So this is a constant function. How many constant functions you can form? This is 1. Another one, instead of 1, you relate every element to what? 5, right? So like that you can find two constant functions. Suppose there is one more element, 3 constant function. One more, 4. So don't worry about the number of elements in the domain. In the codomain, see how many elements are there. In the second set, that many constant functions you can form, right? The number of constant functions from a set containing m elements, first set m elements, and to the set containing n elements. Second set contains n elements, so n number of constant functions can be formed. Now sum number 19, you see, the function 0, 2 pi to minus 1, 1 defined by fx equal to sin x. Please listen here, fx equal to sin x. So sine curve, it will be like this. So 0 to 2 pi, okay, so one full cycle, it will be like this. Sine 0, sine 90 is 1, maximum value 1, minimum value minus 1, 0, 90, 180, 270, then 2 pi, okay, 360. So here the codomain is minus 1 to plus 1. So what they ask, it is 1 to 1 or on to, bijection, or cannot be a function. It is a function or not? Vertical line test, right? If it cuts only 1 point, it is a function. Here it cuts only 1 point. More than 1 it won't cut, right? So it is a function. So this you cannot take. Now listen here. Horizontal line test, you can use it. The vertical line test is to check whether it's a function or not. But in the question they said it is a function. It is a function. So to check it is 1, 1 or on to, 1, 1 or many 1 or on to. So you can use horizontal line test. So what do you do here? In the codomain, you draw which line? You have to draw horizontal lines you draw. Horizontal lines you draw, it must cut. So here, you cannot draw somewhere here, you say it is not cutting. So the value exists from minus 1 to plus 1. In between minus 1 and plus 1, you draw some lines. If it is not cutting, you say it is not onto. If it cuts, you say it is onto. So here it cuts, right? So minus 1 to plus 1, anywhere you draw a line, it cuts. So it is what? Onto. So that is the correct answer. All the 3 cases, okay, so go through that horizontal line test and go through all the particular cases. What's the purpose of that test and how to use that test? Only one point I explained here. Now listen, question number 20. If the function from minus 3 to 3 is defined by, so here minus 3 to 3, to here another function what? S. Then S only they ask, right? Defined by x square, minus 3. When you square, everything will be positive. So here there won't be any negative number. It's starting from what? 0 only. Only 0 and positive values. Maximum 3 if I take, square it, 3 square or even minus 3 square, it is 9, right? So only 0 to 9, it takes the values. So the answer is what? 0 to 9. Now we take question number 21, you see. Very simple question. X, y given. Now this is a 1-1 function or onto function or not a function. Some options given. So better if you draw a arrow diagram, very easily you can find out. Even using this also you can say, see, by seeing this itself you can understand. What you can understand? 2 is related to C, 2 is related to D. 2 has 2 images, so it is not at all a function, right? So if you want, you can, what type and all, better you draw a rough diagram, arrow diagram, so you can understand. X contains X to Y, right? X has the elements 1, 2, 3, 4. Y, A, B, C, D. A, B, C, D. The first one, what they said, 1 is related to A, 4 is related to B, 2 is related to C, 3 is related to D, and again 2 is related to D. So 2 has 2 images, so you know it is not a function. So now listen the next question, question number 22. Inverse already we studied in some video, I taught that, right? How to find inverse. So y equal to something they give. From that you find x value. You will get x value in terms of y, and that is the inverse function. Finally, instead of y, we put x, right? So you take the first one, y equal to x. y equal to x. How can you find the inverse of this? You find x from here. X is equal to y. So this is the inverse. So f inverse is what? Y. F inverse is what? Y. But we write, instead of y, you write x. Okay, this is for the first one. For the second one, you see, second one is fx equal to x square. Fx equal to x square. That is y equal to x square. Find x from here. So x square equal to y, x equal to root y, right? X equal to root y. This is the inverse. So f inverse is root of y. Instead of y, you write x. So f inverse of x. And the last one you take fx equal to 8 root x. Fx equal, that is y equal to 8 root x. I want to find x from here, so square it. Y square equal to 64x. So x is equal to y square by 64. So what is f inverse? This is our f inverse. But instead of y, you write what? X. So x square by 64. So these are the three inverses. X, root x, x square by 64. X, root x, x square by 64. So the correct option is the first one. Okay, listen, question number 23. Let f from R to R be defined by f of x is equal to 1 minus modulus x. The range of f, range with the answer. Listen, the answer is 1 minus something, right? 1 minus something. The something cannot be negative because modulus x, it must be positive, right? So this something can be 0. When I put x equal, even if you give negative value, it will be positive only because we take modulus of that. So from 0 you start. When I put 0, your answer is 1 minus 0. It is what? 1. When I give 1, it is what? 1 minus 1, it is 0. When I give minus 1, for x I am giving minus 1. So what do you get? 1 minus, modulus of minus 1 is what? 1. So 1 minus 1. So what answer you are getting? 0 only, right? Suppose I am giving 2.5. 1 minus modulus of 2.5. What is modulus of 2.5? It is 2.5 only. So 1 minus 2.5 is minus what? Minus 1.5, minus 1.5. Suppose I am giving 20. Suppose I am giving 20. Negative minus 20, even if I give minus 20, your answer is what? Modulus value plus 20 only. So what do you get? 1 minus 20. It is minus 19. So it goes on like this, okay? So it can be 1 or lesser than 1. 1 or lesser than 1. It can be 1 or lesser than 1. That means it can go up to what? Minus infinity. So the answer is minus infinity comma 1. Okay, so now we go for sum number 24. The last two questions, they asked for the function is odd or even. So just recall the formula for odd or even. What's the condition for that? A function fx is given. To check whether it is odd or even, you find f of minus x. If your answer is fx itself, it is even. If your answer is minus fx, the function is what? Odd. E raised to x is always an even function. Cos x is an even function because cos minus theta is cos theta only, right? Then x square or x raised to 4 all even functions. Sin x is odd function, x is odd function, x cube is odd function. But if you put, because instead of x you put minus x, sin minus x. What is that? Minus sin x. Minus x the whole cube. What is minus x the whole cube? It is minus x cube, right? So it changes in sign. So these are even function, these are odd function. Look here. Suppose an odd function, you take minus. Odd function, if you square, it become even function. Yeah, odd function into odd function, you multiply by odd function, it will become even function. Because just odd function, take it as minus. So minus into minus, it is what? Plus. But an odd function plus one even function, that you cannot say anything. Okay. Odd function and odd function, if you add, your answer is odd function. Like numbers you might add, no? So minus 2 and minus 3, if you add it, your answer is minus 5. One plus value, another plus value add, your answer is plus only. But one plus and one minus, one positive and one negative, if you add, it may be positive or it may be negative, depend on sign. Like that you can remember, okay, easily. So here sin x is what? Odd function. Cos x is what? Even function. In between which sign you have? Plus. Odd function, even function. If you multiply minus into plus, it is minus. You say it is odd function. But we are adding to one function is odd function, another one is function is even function. So while adding, you cannot say. So you have to say neither an odd function nor an even function. Now let's go for the last question. The function f is defined like this. It is odd, even only they asked e raised to. So that is an even function. So plus here you see numerator all x square even, cos x even, x raised 4 even, numerator everything even function. Here you see two brackets, x minus sin x, x minus sin x. X is odd, sin x also odd, in between minus odd and odd, subtract, again it is odd function only. 2x minus x cube, 2x minus x cube. 2x is an odd function, x cube is odd function. Both odd function, when you subtract, it is odd function. So odd function into odd function, minus into minus, it is plus, right? So this first term fully it is even function now. Second is also even function. Even function plus another even function. Totally your answer is what? Even function. Okay. So hope you understood all these things, all the 25 sums I taught. So practice more questions. Moreover, the most important thing is if you want to answer any question, don't leave any results, any concepts, learn all the formula, go through your textbook thoroughly. Okay, then you can answer any questions. We'll continue in the next video.